Hi to everyone, myself Dr. Dhananjay Rao, working as assistant professor in the Department of Chemistry. Today I am going to start 4th module, Energy Sources. In this session I am going to cover this topic, Introduction and Classification of Fuels. See, in this session I am going to cover these topics. First one is fuel. What is fuel? The definition of fuel. And combustion. What is combustion process? And classification of fuels. Different classification of fuels. Primary and secondary fuels. What is primary fuel and what is secondary fuel? We are going to discuss. And characteristics of good fuel. Characteristics of good fuel and characteristic properties of solid, liquid and gaseous fuels. I am going to cover these topics. What are those? Fuel. What definition of fuel and combustion? What is combustion process and classification of fuels? And in that, what is primary fuel and what is secondary fuels? Example for primary and secondary fuels and characteristics of good fuels and characteristic properties of solid, liquid and gaseous fuel. We are going to discuss about these topics. Fuel. Fuel is a chemical substance. Fuel is a chemical substance which on combustion produce a large amount of heat. Which on combustion produce a large amount of heat. What is fuel? Fuel is a chemical substance which on combustion. Okay. Fuel undergo combustion, it produces a large amount of heat. It produces a large amount of heat. Fuel on combustion, it produces a large amount of heat. The produced heat is used for domestic and industrial purpose. The produced heat or liberated heat is used for domestic and industrial purpose. Fuels contain carbon, hydrogen and oxygen as main constituents. What are the main constituents in the fuel? The main constituents in the fuel are carbon, hydrogen and oxygen. Okay. A fuel may also contain sulfur, nitrogen, water, okay, etc. These are the contaminants present in the fuel. What is fuel? Fuel is a chemical substance which on combustion. Fuel on combustion, it produces a large amount of heat. Okay, it produces a large amount of heat. The produced heat is used for the domestic as well as industrial purpose. The fuel substances contains carbon, hydrogen and oxygen. These are the main constituents present in the fuels. A fuel may also contain some other elements like sulfur, nitrogen, water molecules. Those are acts as a contaminants present in the fuel. These are the contaminants present in the fuel. Okay. See, combustion. Okay. Already I discussed what is fuel. Fuel is on combustion. It produces a large amount of heat. What is meant by combustion? Any chemical substance on burning, it completely in presence of oxygen is called combustion. Any chemical substance burns completely in presence of oxygen. In presence of oxygen or air is called combustion. Any chemical substance burns completely in presence of oxygen or air is called combustion process. See, the fuel in presence of O2 or air. Okay, in presence of O2 or air, it will undergo combustion. It produces heat and combustible products and non-combustible matter. Fuel undergo on combustion. Fuel on combustion, it produces heat, combustible products and non-combustible matter. See, what are the combustible products? Already I discussed. Fuel contain carbon, hydrogen and oxygen, sulfur, etc. Okay. These carbon, hydrogen, oxygen are the main constituents present in the fuel, and remaining sulfur, water, those are the contaminants present in the fuel. Okay. On combustion, fuel on combustion. In fuel, what are the elements are there? Carbon, hydrogen are there, and sulfur also there. Okay. Carbon reacts with O2. Okay. In presence of O2, it will burn. It produces CO2 gas. Similarly, hydrogen reacts with O2 and forms H2O. And sulfur reacts with O2, form sulfur dioxide. These are the combustible products. On combustion, these are the products formed. On combustion, the fuel undergo combustion and in presence of air. Okay, in presence of air or O2, on combustion, this produces the combustible products. Okay. What is non-combustible matter? After combustion. Okay, after combustion, what are the products present in the fuel? Those are called non-combustible matter. Example, Ash. Ash is the non-combustible matter. It will not undergo any combustion. It will not participate in combustion reaction. That is the non-combustible matter. Example for non-combustible matter is ash. What are the combustible products? Combustible products are the carbon dioxide, sulfur dioxide, water, like these are the combustible products formed in the combustion of fuel. The classification of fuels. Fuels are classified into different types. Fuels based on occurrence and the state. These are classified into two types. Fuels are classified into two types. One is based on occurrence or preparation, and the second one is the state of aggregation. See, based on occurrence. Based on occurrence, the fuels are classified into two types. One is natural fuel or primary fuel. One is natural fuel or primary fuel. Second one is artificial or secondary fuels. Based on occurrence or preparation. Based on occurrence or preparation of fuel, the fuels are classified into two types. One is natural or primary fuels. Second one is artificial or secondary fuels. For first one is natural or primary fuels. The second one is artificial or secondary fuels. And the second type is the state of aggregation. Based on the state of aggregation of molecules, the fuels are classified into three types. One is solid fuels. The second one is liquid fuels. The third one is gaseous fuels. Fuels are classified into two types. Okay, based on two types they are classified. Fuels are classified into two types. One is occurrence, and based on occurrence, and based on the state of aggregation. Okay, based on occurrence, the fuels are classified into two types. One is natural or primary fuels. The second one is artificial or secondary fuels. The first one is natural or primary fuels. The second one is artificial or secondary fuels. And based on the state of aggregation of molecules present in the fuels, these are classified. The fuels are classified into three types. One is solid fuels. The second one is liquid fuels. The third one is gaseous fuels. See, natural or primary fuel. What is natural or primary fuel? These are found in nature. Okay, the natural or primary fuels are found in nature. Example for the natural or primary fuels are wood, peat, coal, petroleum, natural gas. These are the example for the natural or primary fuels. These are found in nature. Okay. Second one is artificial or secondary fuels. Artificial or secondary fuels. These are prepared artificially from the primary fuels. Okay. Artificial or secondary fuels can be prepared from the primary fuels. Okay. These are not found in nature. These are not found in nature. These are prepared by primary fuels. See, example for secondary or artificial fuels are charcoal, coke, kerosene, diesel, petrol, coal gas, oil gas, producer gas, blast furnace gas. These are the etc. These are the example for the secondary fuels or artificial fuels. See here, type of fuel one column, and natural or primary fuels, and artificial or other column. See, in solid state, type of fuels, three types: solid fuels, liquid fuels, gaseous fuels, based on the aggregation of molecules present in the fuel. Okay, those are classified into three types. One is solid fuels, liquid fuels, gaseous fuels. In solid fuels, these are the examples for the primary fuels or natural fuels. In the solid state, similarly, these are the artificial or secondary fuels. See, in natural or primary fuels, see, the wood, peat, lignite, dung, bituminous coal, and anthracite coal. These are the example for the primary fuel or natural fuel present in solid state. These are the natural or primary fuels present in the solid state. Similarly, charcoal, coke, etc. These are the artificial or secondary fuels. These are the example for the artificial or secondary fuels present in solid state. See, in solid state, natural or primary fuels are wood, peat, lignite, dung, bituminous coal, and anthracite coal. These are the example for natural or primary fuels present in solid state. These are present in solid state, and example for the natural or primary fuels. The charcoal, coke, etc. These are the artificial or secondary fuels in solid state. These are the example for artificial or secondary fuels. These are in solid state. The second one is liquid state, natural and artificial fuels. See, the crude oil is example for natural or primary fuel. This is in liquid state. This will be in liquid state. The natural or primary fuel. Crude oil is, example is crude oil. This crude oil is in, the crude oil will be in liquid state. The crude oil is example for natural or primary fuel will be in liquid state. Okay. This is the example for the charcoal. The crude oil is liquid state, natural or primary fuel. The artificial secondary fuels which are in liquid state are petrol, diesel and various other fractions of petroleum. Petrol, diesel and various other fractions of petroleum. These are the example for the artificial or secondary fuels. These are present in liquid state. The petrol, diesel and various other fractions of petroleum are examples for liquid state artificial or secondary fuels. The third one is gaseous. The gaseous state. The natural gas is the example for the natural or primary fuel. The natural gas is example for the natural or primary fuel, which will be in gaseous state. The natural gas is example for the gaseous state, natural or primary fuel. Similarly, coal gas, oil gas, biogas, water gas, etc. These are the example for the secondary fuel or artificial fuels, okay, which are present in gaseous state. These are the example for the gaseous state artificial secondary fuels. What are those? Coal gas, oil gas, biogas, water gas, etc. These are the example for the artificial or secondary fuels and which are in gaseous state. The characteristics of good fuels. See, the characteristics of good fuels. The fuel should contain higher calorific value. The fuel should contain higher calorific value. Means it produce large amount of heat. It should produce large amount of heat. Then only it will have higher calorific value. The good fuel should contain higher calorific value. And the second point is the fuel should contain moderate ignition temperature. The ignition temperature should be moderate for the good fuel. The ignition temperature for the good fuel should be moderate. It should contain moderate ignition temperature. The good fuel should contain moderate ignition temperature. The third point is low moisture content. The good fuel should contain low moisture content. The good fuel should contain low moisture content. The low moisture content fuel is called good fuel. Okay. Low non-combustible matter. Low non-combustible matter. The good fuel should contain low non-combustible matter. The good fuel should contain low non-combustible matter. The moderate velocity of combustion. The combustion rate in the fuel. Okay, the combustion rate in the fuel should be moderate. The combustion rate or velocity of combustion should be moderate in the good fuel. Less toxic combustible gases. The good fuels on burning or combustion or good fuels on combustion, it should produce less toxic combustible gases. That is called good fuel. Okay, the fuel which produces less combustible gases or less toxic combustible gases, those are called good fuels. A good fuel should be readily available in bulk and at low cost. The good fuel should be available in low cost and available in bulk. Those are called good fuels. The good fuel should available in low cost and available in bulky. Okay, available in bulky and easy, and that should contain low cost. That is called good fuel. Handling and transport of fuel should be easy. The handling and transport of fuel should be easy. These are the characteristics of the good fuel. What are those? See, the good fuel should contain higher calorific value. The good fuel should contain higher calorific value. And the good fuel should contain moderate ignition temperature. The moderate ignition temperature should be moderate for the good fuel. The low moisture content. The good fuel should contain low moisture content. The good fuel should contain low moisture content. And the good fuel should contain low non-combustible matter. The good fuel on combustion. The good fuel on combustion, it produces low amount of non-combustible matter. The combustion rate or the velocity of combustion should be moderate for the good fuels. The velocity of combustion or the combustion rate should be moderate for the good fuels. Less toxic combustible gases. The fuels on combustion, it should produce less toxic combustible gases. A good fuel should be readily available in bulk and low cost. The good fuel should be available very easy should be very easy, and it will be available in bulk and low cost. Bulk and low cost. The handling and transport of fuel should be easy. The handling of the fuel and the transport of the fuel should be easy. These are the characteristics of the good fuel. See, characteristic properties of solid, liquid and gaseous fuels. Characteristic properties of solid, liquid and gaseous fuel. See, these are the first column contain the characteristic properties of a fuel. The characteristic properties of a fuel. For solid fuels, liquid fuels and gaseous fuels. These are the variations. See, the first property, the example for the different fuels. See, the solid fuel. Okay, example for solid fuels are coal. Coal is the example for solid fuel. Similarly, for liquid fuel, the crude oil is the example. For liquid fuel, the crude oil is the example for the liquid fuel. Similarly, the coal gas is example for the gaseous fuel. What is the example for solid fuel? The coal is the example for the solid fuel. For the liquid fuel, crude oil is the example. For the gaseous fuel, the coal gas is the example for the gaseous fuel. The fuel characteristic property cost. If you take cost, compare the cost for solid fuels, liquid fuels and gaseous fuels. See, the solid fuel contain cheap in rate. Okay, the solid fuel contain cheap according to cost. According to cost, the solid fuels are cheaper. Okay, if you see the cost of the liquid fuels, it is costlier than solid fuels. The cost, if you compare the cost of liquid fuels, the cost of the liquid fuels is more than that of the solid fuels. The liquid fuels are costlier than solid fuels. If you compare cost for gaseous fuels, it is the gaseous fuels are more cost. The gaseous fuels are very cost. Okay, the gaseous fuels are very cost. The solid fuels contain cheaper and the liquid fuels. The gaseous fuels are more cost in according to cost. The second one is storage. According to storage, the easy to store. The solid fuels can store very easily. The solid fuels can be stored very easily. If you see liquid fuels, for the storing, we need the closed container. To store liquid fuels, we need closed container. Okay, the closed containers should be used for storing. Closed containers should be used for storing. If you take gaseous fuels, the storage space these fuels are the storage space required in huge and should be leak proof. In this case, only closed container need. But in case of gaseous fuel, we need containers. Okay, we need containers, and also there should be leak proof. There should be leak proof. So the storage of solid fuels very easy compared with liquid fuels, and then the gaseous fuels are very uneasy to store. Okay, we need containers, and also that container should be leak proof. The container should be leak proof. The third is risk towards fire hazards. Risk towards fire hazards. The third characteristic property, if you see, the solid fuels, the risk towards fire hazards is less. For solid fuels, the risk towards fire hazards is less. For liquid fuels, the risk towards fire hazards is more. For the liquid fuels, the risk towards fire hazards will be more. Okay. If you take gaseous fuels, the risk towards fire hazards very high, since these fuels are highly inflammable. The gaseous fuels are highly inflammable. See, risk towards fire hazards, if you compare solid fuels, it is less. For solid fuels, risk towards fire hazards is less. Okay. For liquid fuels, the risk towards the fire hazards will be more for the liquid fuels. The risk towards fire hazards will be very high, since these are fuels are highly inflammable for the gaseous fuels. The next point is combustion rate. If you compare the combustion rate in the solid fuels, liquid fuels and gaseous fuels, the combustion rate in solid fuels is slow process. The combustion rate in solid fuels is slow process. If you take liquid fuels, the combustion rate is fast process. If you take the liquid fuels, the combustion rate will be fast process. If you take gaseous fuels, the combustion rate will be very rapid and efficient. The combustion rate is very rapid and efficient in case of gaseous fuels. The next point is combustion control. See, for solid fuels, the combustion cannot be controlled. For solid fuels, the combustion rate cannot be controlled. For liquid fuels, cannot be controlled or stopped when necessary. Cannot be controlled or stopped when necessary. The combustion will not be controlled or stopped when necessary for the liquid fuels. But in case of gaseous fuels, the combustion controlled by the regulating the supply of air. Controlled by the regulating the supply of air. See, if you see the solid fuels, the combustion cannot be controlled in case of solid fuels and liquid fuels. But in case of gaseous fuels, the combustion is controlled by the regulating the supply of air. Okay, by regulating the supply of air. The next property is handling cost. The next property is handling cost. For the solid fuels, handling cost is high. For handling cost for solid fuels is high because since labors required in their storage and transport. Since labors required for the transport and storage of the solid fuels. So the handling cost for the solid fuels will be high. The handling cost will be high for the solid fuels. For liquid fuels, the handling cost is low. For the liquid fuels, the handling cost will be low because the fuel can be transported through pipes. There is no labors required for the transport. Okay, since the fuel can be transported through the pipes, so that the handling cost for the liquid fuels will be low. Similarly, for gaseous fuels, the handling cost will be low. Similar to liquid fuels, these can be transported through the pipes. The gaseous fuels and liquid fuels, the transport can be done by through the pipes. So there is no need of labor. Okay, that's why the handling cost for the liquid fuels and gaseous fuels is low compared with the solid fuels. The solid fuels content handling cost is high for the solid fuels. Ash. The next property is ash. Ash is produced and its disposal also poses some problems for solid fuels. If you on combustion, solid fuels produces ash. Okay, and on combustion, solid fuels produce ash. Ash is produced and its disposal also poses some environmental problems. In liquid fuels, if you take liquid fuels, if you burn or liquid fuels undergo combustion, on combustion, this will not produce any problem because no problem of ash. There will the ash will not be formed in the case of liquid fuel combustion and gaseous fuel combustion. In the gaseous fuels also, there is no problem with ash. It will not form the liquid fuels and gaseous fuels on combustion. They will not form the ash. Only solid fuels on combustion, they produce the ash. Okay. Smoke. The next characteristic property is smoke. See, on combustion, the solid fuels produce smoke invariably. On combustion, the solid fuels produce smoke invariably. For liquid fuels, the smoke is clean, but liquids associated with high carbon and aromatic fuels produce smoke. If the liquid fuels contain aromatic fuels, okay, aromatic carbons, then that will produce smoke. In case of gaseous fuels, smoke is not produced. Gaseous fuels will not contain the aromatic carbons, the aromatic hydrocarbons. So the gaseous fuel will not produce any smoke. The only if you compare smoke in the solid fuel, it is highest in smoke produced will be highest in the solid fuels compared with liquid fuels. Gaseous fuels will not produce any smoke. If you compare the calorific value, or amount of heat, if you compare the solid fuels contain least calorific values. Solid fuels contain least calorific values. Liquid fuels contain high calorific values. If you compare the gaseous fuels, the gas fuels produce highest calorific values. Gaseous fuels produce highest calorific values. The next characteristic property is combustion rate. Combustion rate. It is slow process. So in solid fuels, the combustion rate is slow. In solid fuels, the combustion rate is slow. In liquid fuels, it is fast. The combustion rate is fast in liquid fuels. If you take gaseous fuels, the combustion rate is very fast or very rapid and efficient. The heat efficiency. If you compare the heat efficiency for solid fuels, liquid fuels and gaseous fuels, the heat efficiency is least for the solid fuels and high for the heat efficiency is high for the liquid fuels, and the heat efficiency is highest efficiency for the gaseous fuels. In this class, I have discussed about fuel definition. What is fuel? Fuel is a chemical substance which on combustion it produces a large amount of heat. The fuel, the main elements present in the fuels are carbon, hydrogen, oxygen. These are the main constituents present in the fuel. Fuel may also contain sulfur, nitrogen, water. These are the contaminants present in the water. And the next I have explained about combustion. What is combustion? The combustion is any chemical substance burns on in presence of oxygen completely is called combustion. The chemical substance burns completely in presence of oxygen or air is called combustion. The fuel undergo combustion in presence of oxygen. It produces heat, combustible products and non-combustible matter. I explained about what are the combustible products and what are the non-combustible matter. And the next slide I have explained about the fuels, the classification of fuels. Based on two types of classifications are based on occurrence and based on the state of aggregation of molecules. Based on occurrence, the fuels are classified into two types. One is natural or primary fuels. The second one is artificial or secondary fuels. And the state of aggregation of molecules, these are classified into three types. One is solid fuels, the second one is liquid fuels, the third one is gaseous fuels. See, natural primary fuel. There are found in nature. Example for the natural or primary fuels are wood, peat, petroleum, natural gas, etc. These are the example for the natural or primary fuels. The second one is artificial or secondary fuels. These are prepared from the primary or natural fuels. Example for the secondary or primary fuels are charcoal, coke, kerosene, diesel, petrol, coal gas, these etc. These are the example for the artificial or secondary fuels. These can be prepared from the primary fuels. The different types of fuels, solid, liquid fuels, and these are the example for natural and artificial fuels. These are the good characteristics of the good fuels. These are the characteristics of the good fuels. What are those? The good fuel contain higher calorific value. It should contain moderate ignition temperature. It should contain low moisture content. It should produce non-combustible matter, low amount of non-combustible matter. It should the velocity of combustion should be moderate. It should the good fuels on combustion should produce less toxic combustible gases. A good fuel should be readily available in bulk and at low cost. The handling and transport of the fuel should be easy. These are the characteristics of the good fuel. These are the different characteristics properties of a solid, liquid and gaseous fuels. We have compared in the solid fuels and liquid fuels and gaseous fuels. How the cost, storage, risk towards the fire, okay, combustion rate, combustion control in the different types of fuels, handling cost, all these explained in the in this video. I have explained all those things. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.